So today we're going to review our lesson on lines and angles for the unit assessment. So first we're going to talk about the basic elements of geometry: planes, lines, line segments, go over how to properly notate them when we write them, and then we will move on to using those basic elements of geometry to do things such as solve equations with the segment addition postulate. Then we're going to talk about our angles, our types of angles, how we classify angles, how we notate writing our angles, and then we will go on to pairs of angles, and that will be all of the review. So let's start with basic elements of geometry. So first we have our plane. And on our plane we can have our different elements of geometry. So we can name our plane N. On plane N we will have a line. A line always goes through 2 points. Point A, point B. So that is line AB on the plane N. We can also draw segments. We can make a segment go through a point on the line, so we can make segment BC. On our plane we have different points: point B, point A, and point C. Point B and A are collinear, which means that they are on the same line. Point C and point A are non-collinear because they are not on the same line. We can also draw a ray. So a ray starts at one point. Let's call this point D. And it extends forever in one direction. So to show this, we use our arrows. So D goes infinitely in one direction. A line goes infinitely in 2 directions. So here. A line segment is stuck in between these 2 points. So this is a finite distance. So these are our basic elements. Now to talk about how we notate them. If we have a line, we have line CD, so we want to write line CD. You can say line CD. Or we can also write the 2 points that the line crosses through with the symbol of a line over it. So our line extends forever in 2 directions. So we have arrows on both ends, and there's our line. For a segment is a finite distance between 2 points. F and G. So we can write line segment G. FG, line segment FG, or we can use our other notation like we did with line, where we write the 2 points that the segment is connected between, so F and G, and then we put the symbol of a segment over it, which would just be a line with no arrows because it doesn't extend forever in those 2 directions. Segment FG. For a ray, our ray starts at a point and extends forever in one direction. So we have ray AB. We can again write ray AB. Or we can use our symbol notation, AB with a ray over it. Now let's move on to the segment addition postulate. So we have a segment through 2 points. There's another point in between the 2 endpoints of the segment. Let's call this point J. The segment addition postulate says that segment JZ plus segment JY will sum up to equal the entire length of the segment ZY. So we can add numbers to these. JZ can be 7x, JY can be 2, and ZY can be 15x plus 1. So to use our segment addition postulate, we would add 7x plus 2 is equal to 15x plus 1. From here, we solve an equation. So we can subtract our 2, then we subtract our 15. This is going to give us negative 8x is equal to -1, or x is equal to 1 divided by 8. Then you go back, plug your x in for each of those. So here we plug in 1/8. Here, for this, we plug in 1/8. And then you can get the lengths for each of these segments. Now to talk about different types of angles. We have acute angles. These are less than 90 degrees. We have right angles. These are equal to 90 degrees. Acute, right. We have obtuse. These are greater than 90 degrees. And then we have straight angles. Straight angles create a straight line. A straight line is 180 degrees. So now let's talk about our angle addition postulate, which is similar to the segment addition postulate, and angle bisectors. So if we have an angle, and we have angle YXZ, which we notate angle YXZ with the vertex always being in the middle, and you have some point A in the interior of the angle, then our angle addition postulate tells us that the two separate angles, angle YXA plus angle AXZ, will sum up to equal the entire angle YXZ. So if this measurement is 4 degrees and this measurement is 16 degrees, then altogether 4 plus 6 should give us the angle measurement of YXZ. So the entire angle would be 20 degrees. So that is everything for our review for lines and angles, and good luck.